All right. Hey, Mr. Forden here. I got this great email a few minutes ago. It kind of builds on some questions I got in class today about finding the number of sides, determining the number of sides of a regular polygon when all you know is the measure of an interior angle, one interior angle of that regular polygon. So, anyways, we'll talk about this one here today. This is kind of the hardest situation to kind of figure out, well, how many sides does it have? It's pretty easy to figure out the measure of the exterior angle. Yes, it is. But if you want to go directly from the measure of each interior angle to figure out how many sides there is here, that's kind of like the hardest calculation, I guess. But anyways, here, great email, right? Positive, upbeat. Thank you very much. Thank you for sending this to me. We'll talk about this exact situation here. Okay, so here you have the measure of each interior angle of a regular polygon. So when this happens, when you're thinking about interior angles, maybe you're thinking about that very well-known formula, the interior angle sum formula. So kind of that's where a lot of people's brains go to first is that, well, I know that I have n minus 2 times 180 degrees in total within a regular convex polygon or any convex polygon for that matter here. And I know if I have that, that's my interior angle sum. I know if I divide it by n, that would give me, right, because n is the number of sides, also the number of the angles that are in a polygon. That would give me the measurement of one angle, right? Just one angle of the regular polygon. Because if all the angles in total measure the number of sides minus two, right? Of course, because that's two fewer triangles would get formed by drawing those diagonals in, times by 180, right? That's what all the angles share. And then we got to split that up n ways because we have n different sides, right? Which we don't know how many sides there are, but we'd have n different sides, and each of those angles would be have the equal measure, right? Because it's regular, right? Remember, a regular polygon is equiangular and it's equilateral. Okay, so anyways, that's going to equal what you're given right here, right? You're given this here. You're given here the measure of each or one of them, right? Of an interior angle of a regular polygon of each interior angle. Okay, of a regular polygon. They're asking about regular polygons here. Of a regular polygon. So what you simply have to do, right? This is what you're given, right? You're given this here, right? The measure of an angle of each interior polygon, we know it's going to be equal to n minus 2 times 180 over n. So that's the equation you have to solve. You have to replace 179 with, well, what it represents, which is this right here. And then I have n minus 2 times by 180 and then over n. Now, might be kind of a tricky equation to kind of solve here, right? I got n up top in the numerator, I got n in the denominator. So here we got to do maybe some algebra to kind of help us out in this one. And what you could do potentially, whenever you have a variable in the denominator, one way we can think about setting it free, right, is actually multiplying both sides by n. Because, right, if I'm dividing by n, well, what gets rid of division by a number? Well, it's multiplying by that number. And if I multiply both sides by that same number, I'm going to keep my equation balanced. So if I multiply the left by n, I got to multiply the right by n, and that's nice because I'm going to have n in my numerator, right? I'm going to have no fractions over here. So, anyways, n divided by n is 1, and then I can bring everything else down here. I can bring n minus 2 times by 180, and that's going to equal 179n. Okay. Here, right, to clean this up, I might want to distribute this now. There's no reason to divide by 180 and get really messy over here. So I want to distribute this here. Here, I'm distributing kind of backwards here. So negative 2 times by 180 is negative 360. And 180 times n is 180n equal to 179n. And I'm going to collect my variables. I have more variables over here, so I'm going to bring these ones over to this side, and then the number of variables I have will be positive. So I'm going to subtract 179n, oops, 179n from both sides, 179n, and I'm going to get, right, 179 minus 180 minus 179, I should have crossed out there, it would just equal n, okay? 180 n's, take away 179 of them, I have one n left. So n minus 360 would equal 0 here. Oh, wait, okay? So then I add 360 to both sides. This regular polygon has a lot of sides, has 360 sides. N equals 360. And that answer makes sense for this one. It's kind of weird, like 360, wait, that's the amount of degrees we have in in the exterior angles, for instance, here. We'll check it out here. The 360, if I have 360 sides right here, then that would mean, okay, that would mean the measure of an exterior angle, okay, we use that formula of just 360 degrees divided by n, the number of sides that we have, which is 360. So 360 degrees, because every going around any polygon once, the sum of the measures of the exterior angles in one direction is 360. We divide by number of sides. So if I do that divided by 360, I would get 360 degrees divided by 360 sides, I would get 1 degree as the measure of an exterior angle. So that's that 360 divided by n equals the measure of one exterior angle of a regular polygon. So I get 1 here. And that answer makes sense because 179 plus 1 is 180. And an interior angle, because an interior angle would look like this, an exterior angle, right? We would just extend one side. Those two together would have to add to 180 degrees. Okay. So this is the way that people typically want to do it. There might actually be a faster way, though, kind of a recommended way I tried to talk through earlier, and that is to actually use the exterior angle to get your answer here. Okay. So here you can use this shortcut. Measure the measurement of each interior angle. This is 90 degrees. Well, then what's my exterior angle? Well, the interior angle is always supplementary, a supplement to the exterior angle. So they'd have to add to 180. So this would have to be 90 degrees as well. We're talking a square right now. That's what we're talking, right? If we have an interior angle is 90 degrees, exterior is 90 degrees, and it's a regular polygon, we're talking a square. So our answer here is going to be 4. But I could figure this out by actually just using a different formula, using my measure of an exterior angle. So let's talk about it on this one here. So we have 360 over n equals the measure of one exterior angle of a regular polygon. Okay, why? Because you have 360 degrees as you go around the polygon once, and you count up all the degree measurements of the exterior angles. And if all the exterior angles are the same, you're just dividing by that many that you have, right? They're all sharing that 360 degrees. Okay, so here I can just do 360 divided by, well, I figured out my exterior angle. That was easy enough. Divided by, divided by n. And I'm going to replace this with 90 right here. Okay, and this is a little bit easier to solve. To multiply both sides by n, we get rid of this n down here, and I'd have 360 equals 90n. Divide both sides by 90, and 360 divided by 90, well, 9 goes into 36 4 times. So 90 would go into 360 4 times as well. So 4 equals n. Can fill it on in there. So it's a little bit faster if you get the exterior angle, because then you just got to use 360 over n. You don't have to use this big old formula here. All right. Hopefully, I'm sure that answered your question if you watch this, but hopefully you feel confident in this problem moving forward. Take care. Bye.